This is Chapter 7, Section 7-1, and this is Part 2. And all we're going to do is going to work problems. So we're going to start with problem number 10. And what do we have? We have a function that goes up to 1 and over here to 1 and goes like that and is 0 all the way that way. So f of t is going to equal 0 when for t greater than 1, and it's going to be 1 minus t when I'm between 0 and 1. So that's my function, and now I want the LaPlace transform of it. So the LaPlace transform is going to be integral 0 to infinity f of t e to the minus st dt. Okay, and that's going to be integral 0 to 1 of 1 minus t e to the minus st dt plus integral plus, that's a plus sign, integral 1 to infinity of 0 dt. And one might say 0 e to the minus st dt. That might be a constant, but we're just going to call it 0. So this guy's going to be 0. And all we really care about is integral 0 to 1 minus t e to the minus st dt. Okay, so I got integral 0 to 1 of e to the minus st dt minus integral 0 to 1 t e to the minus st dt. Okay, and so we do the first guy, and we have e to the minus st divided by minus s evaluated at 0 and 1 minus integral 0 to 1 t e to the minus st dt. And so on this guy we're all set. We have I put a 1 in there, and I get a e to the minus s over minus 0 minus 1 over minus s. For the guy on the other side, we have to do an integration by parts. Okay, so we're going to do integration by parts, and we're going to say integral duv is equal to vu prime. No, we're not going to do that. We're going to say that integral u prime v is equal to uv minus integral v prime u. So that's what we're going to do. So this is going to be, put a set of brackets there. What we'll do is we'll get a little bit more room before we proceed. Okay, so there we go, that's better. Okay, well, that being the case, we're going to let v be equal to t, and v prime is equal to 1. And u prime is going to be e to the minus st, and u is going to be minus e to the minus st divided by s. Okay. Okay, I think everything's fine. So I heard a bump, and that confused me, but that was probably something else. All right, so where are we? Back to what we're doing. So I want uv, so that'd be t minus e to the minus st over s, evaluated at 0 and 1, minus integral, it's a minus sign, minus integral 0 to 1 of v prime, which is 1, times u, which is e to the minus st over s. Okay, so I've got e to the minus s over s with a minus sign plus 1 over s minus. Okay, so I put a 0 in there, I'm going to get 0. I put a 1 in there, and I'm going to have minus e to the minus s over s. Okay, and I'm going to have minus, and this is e to the minus st divided by minus s, evaluated at 0 and 1. Okay, so I got, here I have e minus e to the minus s over s, and I have plus e to the s minus s. So those two guys go away. We'll get rid of them in a different color. Boom, boom. So I've got 1 over s minus, that should be a squared. Okay, I put a 1 in. I got a minus sign, I got a minus sign. I have e to the minus s over s squared. But I better keep the minus sign because I have it out there. No, that's the minus sign I have right there, so that's all right. So that makes that a plus sign. And then I put in a 0. So it's going to be minus a minus, which will be minus 1 over s squared. Okay, so it looks like what I'm going to end up is 1 over s plus 1 over s squared minus e to the minus s over s squared. And, oh no, that's not right. So somehow I got my minus signs turned around. How did I get my minus signs turned around? Minus, minus, I put in a 1. Put in a 1, minus, minus, minus. I put in a 0 and I have minus, 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 minus. I put in a 0, so that's going to be that way. That minus and that minus go away, so I end up with a plus. And the first guy, e to the minus st. Interesting. Okay, so up here we have a mistake. I have 0 to 1, but this is a minus. That minus sign there wasn't put there. Okay, so that minus sign has to be put there. Okay, when I do that, that makes this one minus, that one plus, making this one minus, that one plus. And so now I got a final answer. And 1 over s minus 1 over s squared plus e to the minus s over s squared, which checks with back of book, which is just lovely. So don't be dropping minus signs. Number 12. I want f of t is equal to 3 t to the 5 over 2 minus 4t cubed. All right, so the LaPlace transform Right, so f of s is going to be 3 gamma function 5 over 2 plus 1 divided by s 7 over 2. Oh well, can't have everything. Divided by s 7 over 2 minus 4 3 factorial divided by s to the 4th. Okay, so I have 3 times 5 over 2 gamma function of 3 halves plus 1 over s to the 7 halves minus 3 factorial is 6 times 4, 24 over s to the 4th. Okay, then I've got 3 times 5 over 2 times 3 over 2 gamma function 1/2 divided by s7 over 2 minus 24 over s squared, s to the 4th. Okay, then I've got 45 over 4. The gamma function of 1/2 is the square root of pi over 2 divided by s 7 halves minus 24 s to the 4th. Okay, so I got 45 square root of pi divided by 8 s to the 7 over 2 minus 24 over s to the 4th. And this guy checks with back of book. So we got another one right. And now we're going to do 14. Number 14. F of t is equal to t to the 3 over 2 minus e to the minus 10t. And we want to take the LaPlace transform of that. And we're going to use our LaPlace transform table number 7, which you should have printed out. And we're going to come up with f of s is equal to gamma function 3 over 2 plus 1 divided by s 5 over 2 minus 1 over s plus 10. So isn't that nice? Yeah, I paused my phone for an Amber Alert. That's pretty bad. Okay, now this is going to be 3 over 2 gamma function 1/2 over s 5 over 2 minus 1 over s plus 10. And then we're going to have 3 over 2 square root of pi over 2 s 5 over 2 minus 1 over s plus 10. And we're going to have a final answer is going to be 3/4 square root of pi s over 5 over 2 minus 1 over s plus 10. Now, this answer is correct. I have checked it by other means. The back of book is wrong. And I don't know why they did that. I just know that they did. Okay, I'm going to do number 16. Now, why am I doing so many of these for anyway? Well, because we need practice. F of t, sine 2t, cosine, and these sides are just so pathetically easy. That's probably why I'm doing LaPlace transform So f of s is going to equal. Now we're going to use our LaPlace transform number 8 and number 10 off of our expanded sheet. And we're going to call this 2 over s squared plus 4. And we're going to call this s over s squared plus 4. And we are done. And we won't even bother to check it. We'll just say we're done. How's that? That's pretty pathetic. Okay, we'll try another one. We'll try number 18. Okay, we have f of t is equal to sine 3t cosine 3t. We look at our LaPlace transform table and we see, oh darn, we don't have one of them. But from our trig class in 11th grade maybe, we remember that the sine of 2t is equal to 2 cosine t sine t, right? So that means we can rewrite this thing and say f of t is equal to 6 sine 6 sine 2t, sine 6t, sine 6t, 6t. No, we want to divide by 2. Because I don't have a 2 there. It would be sine 6t divided by 2. Okay, so we got there. And then we're going to say we're going to take a LaPlace transform. And we're going to get f of s is equal to, why am I in green? We're using number 8 again. And we have 1/2 6 over s squared plus 36. Okay, and that'd be 3. 3 over s squared plus 36 for our final answer. Okay, we're going to go to number 20. F of t is equal to t e to the t. We're going to use number 15. Take a LaPlace transform of both sides. LaPlace transform of s is equal to 1 over s minus 1 quantity squared. Okay, number 22. Hope I'm not going too fast. Number 22, f of t is equal to hyperbolic sine squared 3t. Okay, so we've got f of t equals hyperbolic sine 3t times the hyperbolic sine of 3t, which is going to be e to the t minus e to the minus t over 2 times e to the t minus e to the minus t over 2. Which is going to be, no it's not. There's a 3 there, there's a 3 there, there's a 3 here, and there's a 3 there. Okay, so I've got e to the 6t minus 1 plus e to the minus 6t over 4. Okay, that seems great. I've got e to the 6t over 4 minus a half plus e to the minus 6t over 4. Okay, Okay, so I'm going to use, now this is my f of t. So I'm going to take and do a LaPlace transform of that. And I'm going to have f of s, and I'm going to use number 7, and number 7, and number 4, and I'm going to have 1 over 4 s minus 6, and I'm going to have minus 1 over 2s plus 1 over 4 s plus 6. And if I'm really clever about it, that I would leave that as a final answer. I really would. But if I did a bunch of algebra, I could get that equal to 18 divided by s squared minus 36. And if I did, and I looked in the back of the book, I'd say, oh darn, that's not in the back of the book. This is, however, correct in the back of the book, for again is wrong. I don't understand why, but it is. And I have other sources to grade to check these things, so that was pretty cool. Okay, number 24. F of s is s to the minus 3 over 2, which is 1 over s to the 3 over 2. We want to find the inverse LaPlace transform. So I look at my table and I say, well, that doesn't make a lot of sense. But if I happen to have gamma function 1/2 plus 1 on top, and I have s 1/2 plus 1 on the bottom, which I do, and I would divide that by gamma function 1 plus 1/2, like that. So I'm gonna do that. Okay, so the gamma function 1 over gamma plus function 1 plus 1/2. That's just a number. So I do a LaPlace inverse LaPlace transform on f of s, and I end up with 1 over gamma function 1 plus 1/2 times t to the what? Times t to the 1/2. Okay, and then I ask myself, well, so this is going to be f of t. Then I'm going to ask myself, well, what is gamma function 1 plus 1/2? Well, it's going to be 1 over 1 times gamma function. That's a gamma function. Gamma function 1/2, t to the 1/2, and that's going to be 1 divided by the square root of pi over 2 t to the 1/2. So that's going to equal 2 square root of t divided by pi, which luckily checks with backup book so that we don't have to go running to other places to figure out what's going on. Okay, so we're going to work with number 26 next. Number 26, f of s is 1 over s plus 5. We see that that's a number 7 in our LaPlace transform table. So we're going to take the inverse LaPlace transform of the whole thing and say f of t is equal to e to the minus 5t. And we are done. We're going to do number 28. And number 28, f of s is equal to 3s plus 1 over s squared plus 4. And we say, well, that is very interesting. Okay, so f of s is equal to 3s over s squared plus 4 plus 1 over s squared plus 4. And we look at our LaPlace transform table and we see number 10 is very close to that guy. Number 8 is very close to this guy. All we have to do is some manipulation. So f of s is going to be 3 times s over s squared plus 4. That's not much manipulation there. Plus, we want a 2 on top. From number 8 says we need a 2 on top. So this is going to be 1/2 2 over s squared plus 4. Now we take the inverse Laplace transform of the whole thing, and we say f of t is equal to 3 cosine 2t plus 1/2 sine 2t. And we find that that one checks, so that's good. That was 28, I think. 28. Okay, we're going to do one more and call it a day. Number 30. Okay, I have f of s is equal to 9 plus s. That's a 9. 9 plus s, 4 minus s squared. And I want to do an inverse Laplace transform to find out what f of t is. So I'm going to have f of s is equal to 9 divided by, we're going to make it minus 9. Minus 9 s squared minus 4. And we're going to make it minus s over s squared minus 4. Now why is that? Well, because we know that that's going to give us the hyperbolic cosine stuff. Okay, so we're going to hyperbolic sine, hyperbolic cosine. So we're going to go like that, and we say, well, this guy needs a 2 on top. So I'm going to bring minus 9 over 2, 2 over s squared minus 4. And then this guy's just going to be s over s squared minus 4. And we do a inverse Laplace transform. And the hyperbolic sine and cosine guys are in your book in table 712, or figure 712. Not on the sheet I gave you, I don't think. So f of t is going to be minus 9 over 2 hyperbolic sine of 2t minus hyperbolic cosine of 2t. And I lied to you, we're going to do one more. So we're going to do one more, and it's going to be number 32. And so f of s is equal to 2 over 3 e to the minus 3s. And we're going to go and take the, we recognize, no, that's 2 over s, not 2 over 3. Put the right problem down. 2 over s, e to the minus 3s. And looking at the Laplace transform table that's in the book, we find that this is, that f of t is going to be 2u t minus 3. And that's the unit step function at t minus 3. So, what is the unit step function? So u of t looks like that. Goes, starts here, goes there, boom, up to 1. U of t minus 1, there's a 1 there, and it looks like that. It goes boom, up to 1. U of t minus 3, 2 ut minus 3, would come out to 3, go up to 2, and boom, do that. And with that, we are done with section 7-1. Okay, thank you.